The objective today is to describe the importance of internetworking devices to an access point. So here's our table of contents. We're going to first talk about networking in the Stone Age, so a long time ago. That's my little picture of a dinosaur guy there. And then we're going to go into electrical concepts. These are just things you would need to know for a lesson like this, kind of just need to know why we're using these devices in the first place. Some of them may seem almost senseless to you, but once you learn about how electricity works, then it will come together for you. And then thus that concept of wire gauge will piggyback on that particular point. Then I'll finish the lesson by specifically talking about hubs and switches. So we've studied switches and hubs before, but back then I did not go into the importance of the concept of a repeater. Back then you had just learned that these switches and hubs are connecting multiple computers together, so just something really simple. Now we'll use all those devices to assist us in understanding how small networks can be created and supported. It's very difficult to support a network like this, and this is what the old school networks used to look like. It didn't take us very long before we realized that this was a really bad idea. So before I tell you why it was a bad idea, can you make a prediction? What is so wrong with this? So if you said anything about wasting electricity or maybe wasting time, these are definitely right answers. And as you may have guessed, if computer F over here is being sent a message by computer A, you're only as strong as your weakest link. If one of these computers is down, computer F will not be getting that message. And this might not be surprising for you to learn, but this severely limited the length the cable could be because each computer wasn't even designed to amplify or increase the voltage of the message that is being sent through it. So this picture is a good one to associate with the concept of having a repeater. As voltage goes through the air or through a wire, those ones and zeros start to lose some electricity. So to fix this, engineers created a concept called a repeater. Now remember, when we've talked about using a 5-volt supply before in class, if we're using a 5-volt supply, anything between 2 volts and 5 volts is recognized as a logical 1 value. So when we're sending our ones and zeros, there's going to be a variety of different types of ones, and as long as they're in this range, we're good to go. Now, if you have some sort of voltage that drops below 0.8, this is now a 0. If there is a decrease in voltage because that power has to go through 100 meters of cabling, our data will be corrupted. Or as I say in this slide, our data will be lost in transmission. And why is this lost in transmission? Well, because Ohm's law describes how the amount of power in electricity and its characteristics, that is voltage, current, and resistance, are related. So it boils down to this: losses scale with the square of a wire's current. That square factor means a tiny jump in current can cause a big jump in losses. Keeping voltage high lets us keep current and losses low. So to learn more about this, I found a good website called InsideEnergy.org where they had this article about how as power is distributed to your household plug, it is losing power on its way there. And of course, there's different ways to create energy, right? We got coal, petroleum, natural gas, and nuclear energy. And we won't go too much into why or how this is happening, but if you're artsy, here's a cool poster to wrap your mind around the equations they use for this. Now, when shopping for Cat5e, Cat6, or Cat6a network cables, you may notice that an AUG specification is printed on that cable's jacket. So you might see something like 24 AUG. Well, the AUG stands for American Wire Gauge, and Cat5e is rated at 100 meters. So your ones and zeros will stay intact up to 100 meters of cable. If you go any longer than that, you're playing with fire. You might have some problems in your network. So if we're talking about other cables like USB and HDMI cables, length is particularly important. Before, I'm just talking about like internet cables. So if you're trying to play a movie from your Xbox to your television using an HDMI cable, you want as short of one as possible. It's easy to remember the recommended length of a USB 3 cable. USB 3 has a maximum length of 3 meters. But the quality of your HDMI cable, it's my understanding that this is true, does not matter nearly as much as the length of the cable. Be careful here because we might be talking about analog cables. These are VGA, and in that case, thickness plays a role as well. not just length but thickness. So if you are interested in this stuff, just Google the word like electrical reflections and you'll learn more. I have to focus on networking here, but before I finish, just know that there's a difference in digital cables and analog cables. This is VGA and this is USB, and the way ones and zeros are transferred in these are different. And check this out, some cables have a little repeater built inside of them. That way from this point to that point, this is a USB cable, that way from this point to that point, the ones and zeros don't disappear on you. And all USBs, if you were to break them open like this, has a little chip like that there. But if you broke this one open, you're going to see another semiconductor that is designed to boost the cable's performance. So that's why this cable is called an active cable. It's actively boosting the signal. While if you see regular ones at your house or at the school, these are just passive cables. And you might be able to take a cable and plug it into something like this to make it an active cable when it was originally a passive one. So specifically, what is an active cable in your own words? And now you might understand a little bit more about a hub, because we've talked about how silly hubs may seem, because whatever, you have your input here and the output is going to be given to every single port. Hubs are kind of funky that way, but hubs are very important if they're acting as a repeater. I've always had a hard time understanding why somebody would use a hub instead of a switch. But if their needs are just for a repeater, then that makes a lot more sense. A hub is particularly cool if you think about what it's doing, because not only is it boosting the signal, it's doing this thing where it like cleans out what's called electrical noise from the bits, and it just makes them clear in that sense. It regenerates the signal at full strength and blasts that new data out to all the computers that it's connected to. Makes me think of a picture from Destiny there with their big ol' satellites. And in that case, think of like your teacher as a hub. When you think of a hub, think of this little lizard guy. This little guy is like the best bit. The teacher is trying to get you from one place in your mind to another, from one stage of life and stage of learning to another. Thus they are acting as your hub. They're amplifying who you already are. And now hubs will often play a role in the bandwidth a network can have. Remember, bandwidth is the amount of data being transferred, and we usually see speeds between 10 million bits per second to 10 billion bits per second. And you see I'm using the word million and billion when you usually hear megabits and gigabits. At least the first one is easy to remember because they both start with an M. So quick think rate share, what is the typical range of bandwidth in a network? Now something else you should probably understand is just how like the lights on these things work, lights on a hub or lights on a switch. This first one, at least for this particular one, is a 5 gigahertz solid blue light to let you know you're working at 5 gigahertz. And on a separate channel here, you might have 2.4 gigahertz. So if another light might just indicate that the hub is ready. A solid blue indicates that the Super Hub 2 AC has completed its registration with the Virgin Media Network, company who made this particular one. And again, this is just an example, so whatever hub or switch you have, you can look up the information like this on the lights. Something to keep in mind is this Wps button. By pressing this button, it allows you to use a Wi-Fi protected setup, WPS, to add a wireless device or computer to your network. So that's a cool feature where you just press a button and now you can connect. And there's so many different types of status lights. You would have to look it up at a website like this to just understand what you're looking at. And I'm bringing this up too because for a long time I did not know how these people who played with breadboards and electronics were so obsessed with LEDs. Well, the idea that information is being transmitted to you, the human, through LEDs was an aha moment for me. You can use lights and patterns of lights to mean so many different things, and when you're at the low level like this, you're the one who is determining what the lights are meaning. So now that we've seen some lights on a switch, let's talk about switches. Take a guess, or if you know, tell me what you think the difference between a hub and a switch is. The easy way to remember this is switch is smart. It analyzes the data, called a frame, so we have data, IP, and a MAC address inside of a frame. So the switch looks at the frame and analyzes it, while the hub just gets it and shoots it back out. It's a repeater. It's just increasing its signal. If you ever hear of something having a switching table in it, then you know you have a switch. Because in that switching table is MAC addresses of particular computers. And within the frame, when the data comes to the switch, if the computer's MAC address is not the one the data is for, then that switch will not send it to all the computers, thus saving electricity. So since we do live in a world that is much more concerned with saving electricity and just being more efficient in general, you'll see people using switches because of all the limitations that a hub has. The hub can only send or receive data. It can do this in half duplex mode. The switch can do this simultaneously, so full duplex is the fancy term for it. And also, the switch does not have to share bandwidth. It can dedicate certain amounts of bandwidth with specific ports. So I assume some ports that are used quite a bit, like HTTPS, is maybe a priority port. If you have POP3 for email, port 110, that might be noticeably slower for you. I've definitely gotten emails on my phone before I've gotten them on my computer, and I've wondered why that is. So my think right share for you is, what is the advantage of having a switch? And just so you know, for both hubs and switches, you should be able to find an uplink port so that you can connect a hub to a hub or a switch to a switch. And thus you'll be able to extend your network significantly. So here's some more vocab. What is uplinking? Just before I end the lesson, I wanted to share this meme because it just reminds me of a switch. Just because you have data coming in doesn't mean you have data coming out if the MAC address for that data isn't in the switching table of the switch. So that's the end of the lesson. Which one of these IB attributes connects to today's lesson? By paying attention and working hard in class, are you more caring? Are you more principled now that you know about how electricity works with hubs and switches? And of course, here's our DOL. Describe the importance of the devices you see in this topology, and I'll give you a hint. First, identify the devices, and then identify what they are connecting to. Give me additional details that you can using the vocabulary you got from this lesson. Some examples would be the concept of sharing bandwidth, the word full duplex, switching table, uplink port, repeater, bits, Ohm's laws. These are the things that you could bring up in your answer.